Alright, so now we're into adding and subtracting rational expressions, and this is a little bit more complicated, as you could imagine, because when we add fractions we need a common denominator. So let's just review the idea of adding numerical fractions, and this involves getting a common denominator, equal slices of the pie if you wish, and what we need to do is we need to bring up our denominators to the same level. So our two denominators here have a factor of 2 and a factor of 3, and since we need to bring them up, we need both of those fractions to have factors of 2 and factors of 3. So what we do is we multiply top and bottom of this fraction by what we're missing. Alright, because 2 over 2 is just 1, and 1 times anything doesn't change the value of this. And then over here we need to bring our denominator up. And we can do that if we multiply top and bottom by 3. And so we have a common denominator of 6, and our numerators are 4 and 3. And then we can add our numerators to get our answer and simplify the answer if needed. In this case we don't. Alright, so we need to get a common denominator, as we said, to add and subtract rational expressions. So let's start off. First example, we have a common denominator. So we know that this is going to be out of n, and as we did with numerical fractions, once we have the common denominator we just add the numerators, or subtract them in this case. So we're going to go m minus, now I've got to be careful here, I need to bracket this next section because the negative is going to apply to everything up here. Alright, let's simplify our answer. So we have m distributing the negative through, cancels out, and our answer is 1 over n, negative. Our restriction, by the way, going back to the beginning, is that n can't be 0. Alright, in our next example we do not have common denominators, so what we're going to need to do is bring up each of these to the same level. Okay, so our lowest common denominator, you can see that both of the denominators are factored. We have x times x, and here we have x times y. So I have 2 factors of x here, I have 1 factor of x here, which means I'm going to need 2 factors of x in my lowest common denominator. Okay, here I have 0 factors of y, here I have 1 factor of y. I'm going to need a y. I need to bring both denominators up to the same level. So I'm going to take 1 factor of y. This will be my LCD. So in order to get the LCD in this fraction, we're going to need to multiply numerator and denominator by y. And in this fraction, multiply numerator and denominator by x. Remember, this is just 1, so anything times 1 keeps the value of that fraction the same, and similarly here. Alright, so our denominator now is x squared y, which is common, and on the numerator I have 3y squared plus 4x. Now I have to consider whether I can reduce my answer, simplify my answer. The denominator's factored. On the top, that's 1 chunk. 1 times that chunk, there's nothing else I can factor that chunk down to, which means I'm done. That is my answer. Just to remember restrictions we do from the beginning, x can't be 0 and y can't be 0. Alright, our next example, getting a little bit more difficult. You'll notice here we have a denominator that can be factored, so we should always begin by factoring our denominators in particular, because we're going to need to find a common denominator. Our restriction will be that p cannot be 1 or negative 1. Now our lowest common denominator, remember, must contain the greatest number of any factor that appears in the denominator of either fraction. Let's just bracket that to remind us that that's a chunk. So what that means is I have a factor of p minus 1 here. I don't have it over here, so I'm going to need that to bring both denominators up to the same level. Here I have a factor of p plus 1. I've also got that here, so I don't need to add anything more. P plus 1 is in both. That's part of the common denominator. Alright, so to bring our fractions up to the common denominator, this fraction already has both components of our LCD. This does not. We are missing a factor of p minus 1. So we can multiply top and bottom by p minus 1. And so my factor p plus 1 times p minus 1. And on the numerator I have 4 plus 3 times p minus 1. I can distribute this to simplify. That'll be 3p minus 3. So that's going to reduce the numerator to 3p plus 1 divided by p plus 1 times p minus 1. And now I need to see if I can simplify my answer. My denominator's factored. My top is factored as far as it can go. That's a chunk times 1. And there are no common or opposite chunks. So this is my simplified answer. If I plug a given value of p into the end and into the beginning, I will get equivalent fractions. Alright, so just before we move on to the next example, I think the trickiest thing with adding and subtracting is finding the common denominator. And we want the lowest common denominator just to keep things as simple as possible. So, as I've been saying, I've written it out here just so you can see it. The lowest common denominator must contain the greatest number of any factor that appears in the denominator of either fraction. If a factor appears once in either or both, include it only once. So for example, in my last example, p plus 1 was contained in both, so I didn't have to include it twice in my LCD, I only needed to include it once. If a factor appears twice in any denominator, then you need to include it twice. So another example, we're going to begin by factoring our denominators. It's a trinomial x plus 3 times x minus 2 minus x minus 2 times x plus 3 times x plus 1. Of course, there are restrictions. Indicate the restrictions if needed or if you're asked to. So our LCD contains the greatest number of factors that appear in the denominator of either. Okay, now you'll notice that x plus 3 is in both, so we include it once. X minus 2 is in this one, but not in this one, so we need to include it. There's one factor of x minus 2 there. There's none here, so we need to include the greatest number, which is one factor. And similarly with the x plus 1. There's a factor here, it's not here. We need to include it, x plus 1. So our LCD is here. So what we need to do now is bring each fraction's denominator up to this level. So on fraction 1, we have 2 of the 3 needed factors in the denominator. We are missing x plus 1, so we need to multiply x plus 1 on the numerator and denominator, like so. On this fraction, we're missing the factor x minus 2 in the numerator and denominator, times that. Okay, just keep the brackets there because remember those are chunks on the top. So our common denominator, x plus 1 times x plus 3 times x minus 2, and our numerator is going to be x plus 1 times x minus 1 minus x minus 2 times x minus 2. Alright, we need to simplify this expression. Now, we can't do any canceling here because we don't have factors on the top. Remember, we can only cancel when we have everything completely factored. The denominator's factored, everything's multiplied, but on the top we have chunk times chunk minus. The minus breaks up the multiplication. So what we're going to need to do is bust this apart, essentially, and then refactor it if needed. So, on the numerator, multiplication of these two binomials, x squared minus 1 minus, and then I'm going to put the answer to this in brackets, x squared minus 4x plus 4 all over my LCD. Distributing the negative on the numerator, x squared minus 1 minus x squared plus 4x minus 4 all over the denominator. And we have some canceling out happening on the numerator. We have 4x minus 5 left, divided by the factors in my denominator. Alright, so my top, that's a chunk again, times 1, and that chunk doesn't reduce, doesn't factor, which means it's different than the ones below, which means there's no cancellation, which means we're done. Alright, one more example, and this is an example of something we call a complex fraction, and that's when we have fractions within the big fraction. Okay, how can we simplify this expression? Now there's a few different things you need to consider in terms of restrictions. First of all, each of the individual fractions cannot be undefined, so for example y cannot be 0. And in addition to this, this whole thing cannot be 0. So if I were to multiply both sides by y squared minus 4 could not be 0, which means y could not be the square root of 4, plus or minus 2, my restrictions. Alright, now you don't need to state restrictions necessarily unless you're asked to, but you should also always be mindful of them because they can affect the question depending on how you're going to use the result. Alright, let's look at this one particular way. So method 1, what I'm going to do is I'm going to get a common denominator in my numerator and in my denominator. So in my numerator, the common denominator would be y. So I'd need to multiply top and bottom of this fraction by y to get a common denominator. Actually, the same thing with this denominator. So I'm going to write 2y over y minus 4 over y. And on the denominator, y squared over y minus 4 over y, which can be written as 2y minus 4 over y divided by y squared minus 4 over y. So what I've essentially done is I've changed this question. I've used my addition and subtraction skills to get the numerator and denominator into one big fraction. And now what I'm doing here is I'm basically dividing. So the top rational expression divided by the bottom one, which would be multiplication of the reciprocal by the reciprocal. So I've now changed this into a multiplication question. And I can factor in a few spots here. Common factor of 2. This y and this y are going to cancel out. We're canceling out across a multiply sign, that's fine. Y minus 2 times y plus 2. And so those cancel out, common factors, and we're left with 2 divided by y plus 2. Alright, now there's another way you can do this. Instead of getting a common denominator in the numerator and denominator, what you could do instead is multiply the numerator and denominator of the big fraction by the lowest common denominator of the mini fraction. So the common denominator of the mini fractions would be y. And so I'm going to multiply the big fraction top and bottom by y. Okay, remember this quantity is 1. 1 times anything is that same thing. It might look different, but it's the same thing. Alright, so I'm going to multiply by y top and bottom. I can distribute that across to both. So on the numerator I get 2y minus, and I multiply these two things, the y's are going to cancel out. Right? 4 over y times y over 1. So I just have 4 over y squared minus 4. And now we're going to simplify, factor out our 2. You can see it's similar work from method 1. And so we come to the same result. So just to wrap up this section on adding and subtracting rational expressions, which as you can see is pretty involved. So what you need to do to start off with is factor your denominators, because you need to come up with a common denominator, and in order to keep your common denominator as low as you can, you want to identify any parts of the denominators that are already the same. So we find the common denominator, as we had indicated, by taking the largest number of each different factor between the given denominators. You write each fraction with the LCD, so you bring each of the given denominators up to the level of the lowest common denominator. You then add and subtract the numerator, and then you simplify as needed.